Hey, if you're studying for the MCAT, this video is for you. Displacement and velocity are high-yield topics in the chemical and physical foundation section, and students often lose easy points by mixing up vectors and scalars. The exam doesn't just test formulas, it tests whether you understand the difference between displacement and distance, or velocity and speed. In this video, we'll break down these concepts step by step so you can avoid the common traps the MCAT loves to set. Displacement versus distance. Displacement is a vector. It only cares about where you start and where you end in a straight line. The symbol is delta x and the units of length. Distance is a scalar. It's the entire path traveled. No matter the twists and turns, the symbol is d, and it's always positive. Quick check. If you walk around the block and end where you started, your displacement is 0, but your distance is the whole block. Velocity versus speed. Velocity is a vector. It's displacement divided by time. V equals delta x over delta t. Direction matters. Now, speed is a scalar. It's distance divided by time, delta d over delta t, no direction. That's why you can have the same speed but opposite velocities. The MCAT loves that twist. Instantaneous velocity. Think of it as velocity at one exact moment. On a graph, it's the slope of the tangent line to the position curve at that point. That's calculus in action, but on the MCAT, it usually shows up as reading graphs correctly. Average velocity. Total displacement over total time. Straightforward but easy to confuse with average speed. Average speed cares about total distance. Average velocity cares about net displacement. Uniform motion. If velocity stays constant, both the magnitude and the direction, then the motion is uniform. The formula is delta x equals v times delta t. This shows up when the MCAT gives you a simple graph or description with no acceleration. Acceleration. Acceleration is the rate of change of velocity. A equals delta v over delta t. It's a vector, and the units are meters per second squared. On the MCAT, watch for cases where velocity is constant. That means acceleration is 0, even if the object is moving fast. So that's displacement and velocity, from scalar versus vector quantities to instantaneous and average velocity and even acceleration. On the MCAT, the key isn't just memorizing formulas, but knowing which one applies in context. For example, constant velocity means 0 acceleration, a favorite test day trick. With that said, here are just a few of our student success stories. Students who mastered these concepts, boosted their scores, and got into medical school. If you're studying for the MCAT, click the link below to get started with your own prep. We help students reach a 515 plus on the MCAT, and we'd love to do the same for you. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.